This place behind me is Sejong Building of K-Water, and I'm Yongshin Lee working in this place. K-Water constructed this building in 2018, and now all the water management data and technologies are gathered, including Water Resources Management Center in this place. Now, let's go inside. Here is K-Water briefing room. In this place, I'd like to introduce water management history of Korea. In Korea, we have 1,300 millimeters of rainfall every year. It is 1.6 times greater than global average. However, the amount of water that every single person can use is much smaller than global average due to high population density. Korea has many unfavorable conditions to manage water resources. At first, Korean annual precipitation is concentrating in the summer season. That's why we have to concern flood event in summer and drought event in winter and spring. Secondly, it is based on geological characteristics of Korea. Korea is a peninsula which is covered by the sea, and 65% of lands are mountainous area. So when rain comes, it directly flows into the sea. That is the reason why we need to construct dams or reservoirs. As I mentioned earlier, Korean rivers such as Han River, Nakdong River are very steep comparing with the other rivers like Seine River in France and Mekong River in Asia and Mississippi River in the US. Have you ever heard about the river regime coefficient? This coefficient represents the ratio between maximum flow and minimum flow in the river. If this coefficient is big, it means the river is unstable. Korean rivers such as Han River, Nakdong River, Gyeom River has over 300 of river regime coefficient, whereas Seine River in France, Rhine River in Germany, Mississippi River in the US has under 40s. In the end, we can say that Korean rivers are naturally very unstable. Now, I'd like to talk about Korean water management history. Korea was the most poorest country in the world in 1950s due to Korean War. Since the Korean War, Korean government tried to make an economic growth. However, frequent flood and drought disasters was the biggest obstacle. Now, you can see the picture about flood event in Korea. And there were extremely severe drought events too. In early 1970s, Korean government commenced a river basin survey under the loan and technical support from UN and Japan. After the survey, we started to construct large dams such as Soyangang Dam, Andong Dam, and Daecheong Dam. The blue line here means total storage volume of major dams, and orange bar here means GDP per capita. Since we construct large dams, flood control and drought management could be possible. Then finally, we could make an economic growth as you see here. We call water resources development period from 1970 to 1990. However, people start to think about more about the quality of water and environment since 1990s. So it's getting difficult to secure water resources in the environmental period here. In IWRM period, water resources development has almost stopped. Water is finite resources. In order to use finite these resources, we need to introduce the integrated water resources management That's why we call this era as IWRM period. There are over 17,000 dams and reservoirs in Korea. Most of them are small and agricultural reservoirs. And we only have 20 multipurpose dams. However, those 20 multipurpose dams form almost 70% of total effective storage volume. K-Water, as a bulk water supplier, we supply 60% of total water storage of Korea and operate 95% of flood control capacity, generate 60% of hydropower of this country. However, there are many challenges caused by climate change. Korea Flood Risk Index is the highest level in the OECD countries, and we are facing drought problems almost every year. To overcome those challenges, we need to realize integrated water resources management, IWRM. K-Water operates water management center in 4 major rivers and 1 headquarters center in Daejeon City. We are remotely operating 37 dams and 60 weirs and 25 hydropower plants. The main scope of work is flood control, water supply, and hydropower generation. To operate water resources in a reasonable manner, it is highly required to have smart water management systems. K-Water developed K-Water Hydro Intelligent Toolkit called K-HEAT. K-HEAT consists of 5 subsystems: RHDOPS for data management, PFS for precipitation forecasting, FAS for flood management, RWSS for water allocation, and finally GIOS for hydropower generation. First one is RHDOPS, Real-Time Hydrological Data Acquisition and Processing System. When we operate water resources, we need many kinds of data such as water level, rainfall, water quality, and quantity information. Every 1 minute, we measure those data from the sensor and automatically transmit it to Water Management Center and Dam Office. For the stable data communication, we are using dualized network system with satellite and CDMA. Next one is PFS, Precipitation Forecasting System. Korean Meteorological Administration, KMA, provides weather forecast to the public. However, K-Water also generates precipitation forecasts for water resources management. With the data from KMA and NOAA, PFS simulates is implemented. PFS can provide watershed-based precipitation forecast 4 times a day and 5 days forecast. If PFS system forecasts the rainfall, then flood analysis is required. With FAS system, flood analysis system, we can simulate how much water will rise and how much water we have to release to the downstream. Also, it is possible to simulate 2- and 3-dimensional downstream inundations, as you see. Next one is RWSS, Reservoir Water Supply System. K-Water established dam operation schedule in monthly basis. When we decide operation plan, we need to consider the downstream and watershed conditions such as water demand, runoff from the tributaries, and water balance and quality. RWSS provides total decision support to create an optimized water supply plan. The last one is GIOS, Generation Integrated Operation System. We can remotely control 25 hydropower plants and 79 generators with GIOS system. Simply speaking, we can turn on and turn off the nationwide generators at the water management center here. Only 4 engineers are required to operate over 1,300 megawatts. That covers my presentation. Thank you for your attention. And now I'd like to show you real Water Resources Management Center. Thank you. Here is a Water Resources Management Center of K-Water. You can see the big board that shows almost every aspect of water management of the country. In this room, we are operating water resources facilities such as dams, reservoirs, and the runoff river wells every day, 24/7. Basically, we are monitoring hydrological information to cope with water disasters such as flood, drought, and water contamination events. First frame you see here is called RHDOPS, Real-Time Hydrological Data Acquisition and Processing System. We can monitor hydrological information such as water level, storage volume, precipitation, as you see. Those data can be updated every single minute from the in-situ stations and transmitted here Water Resources Management Center. In Korea, we have frequent heavy rainfalls, monsoon, and typhoon. That's why we need to monitor real-time based data. In this part, we can see real-time CCTV video of the important spots such as spillway of the dams. We are monitoring every dams 24 hours a day, just as you see here. Next frame shows meteorological information. This is real-time satellite image comes from Korea Meteorological Administration here. And also, this shows radar image, which shows current precipitation status here. However, this image shows weather forecast for the future. K-Water's Precipitation Forecasting System, PFS, can provide a weather forecast for the next 5 days in dams watershed, as you see here. Those videos looks like just one of the CCTV. Yes, but it is monitoring very critical spot that is shared river between North and South Korea. In Korea, we have 2 main shared rivers between North and South. One is the North Han River, and the other is Imjin River. Upper one is showing northernmost Han River, and a lower one is Imjin River. There were many accidents caused by the water release from the north without any notice. Especially in 2009, 6 people had to die due to this accident. Now, we completed to construct flood control dams between those shared rivers. That's why we don't have any accident nowadays. In this video, if the water level rises up to 1 meter, then it automatically alarms to the people who living in that regions and the Ministry of Environment and K-Water as well. Also, the flood control dam located in the downstream start to open the gate according to the manual. Last one is GIOS, Generation Integrated Operation System, that control hydropower generation. There are names of the dams. And those circles here are the number of hydropower generators. Red one means it's operating, and green one means it's stopped. In this room, we are remotely controlled 25 hydropower plants and 79 generators all around Korea. In short, we can remotely turn on and turn off those generators in here. We can handle over 1,300 megawatts capacity of nationwide hydropower with only 4 engineers by this system. Now we have briefly looked over Water Resources Management Center of K-Water. In summary, we are monitoring and make decisions with diverse scientific water management systems to overcome water disasters and to operate water resources more efficiently. I hope this has been helpful for you. Thank you so much. Bye.